Welcome to this explainer. Today, we're diving headfirst into the absolute chaos that is mobile app observability, and we're going to figure out exactly why the old ways of doing things just don't cut it anymore. Let me paint a little picture for you. Imagine it's launch day for a massive, highly anticipated new feature. You're sitting in the engineering war room, eyes glued to your back-end infrastructure dashboards. Everything is perfectly green. CPU utilization is super steady, database latency is rock bottom, and your API gateways are just returning a beautiful sea of successful responses. You should be popping champagne, right? But then you open up the App Store, or maybe you peek at your customer support queue on Twitter, and the reviews are absolutely tanking. Users are furious. They're reporting that the app is completely broken. Now, if you've ever lived through that incredibly frustrating dichotomy, staring at a flawless server dashboard while the actual user experience is on fire out there in the real world, well, grab a seat. You are in exactly the right place.
Think of this explainer as your comprehensive survival guide for the most hostile environment in software, the user's actual device. Here is our roadmap for today. We'll start with number 1, the front-end Wild West. Then we'll hit number 2, overcoming mobile domain challenges. In section 3, we're looking at local storage and real-time solutions. After that, we'll dive into number 4, centering the user experience, and we'll wrap up with number 5, a real-world case study on the Fake Burger app.
All right, let's jump right into section 1, the front-end Wild West. We really need to set the stage here, because the contrast between where we write our code and where it ultimately ends up running is honestly staggering.
This comparison brilliantly illustrates our core problem. We are trying to observe a chaotic, heterogeneous sandbox, but we're using tools and mental models that were built for a perfectly controlled back-end server. Think about it. On the back end, you are the absolute dictator of your environment. You fully control the deployment pipeline, you pick the exact operating system, you provision the CPU and the RAM, and everything operates on a heavily fortified, uniformly fast network. It's like a temperature-controlled greenhouse. But on the front end, and especially on mobile, you are merely a guest on someone else's device. You inherit an incredibly hostile environment. You're dealing with tens of thousands of unconstrained device variations. You've got everything from a brand new flagship iPhone to a 6-year-old budget Android with a completely fragmented memory disk. You have to navigate spotty, constantly shifting cellular networks. You're up against aggressive operating systems that will just terminate your app's background threads to save battery, and concurrent processes that you have absolutely zero control over. Observability here doesn't happen in your perfectly manicured backyard. It happens beyond the fence in actively hostile territory.
So, in the face of all that chaos, it is super common to hear mobile development teams proudly boast that their mature apps have a 99.9% crash-free session rate. And sure, that sounds incredibly impressive on a performance report, but honestly, it often breeds a dangerous level of complacency. Mobile and web devs kind of start feeling that if the app isn't explicitly crashing to the home screen, then the current state-of-the-art tooling is doing its job and is, good enough. But I'm here to tell you that this 99.9% figure is a massive trap. Let's do a little conversational math on why that complacency is so dangerous. If you have a highly successful app with 100 million active devices, even a tiny 1% failure rate means 1 million broken user experiences. Even 0.1% means 100,000 users having a terrible time. The crucial takeaway here is that a massive amount of your users are suffering from non-crashing performance issues. We're talking about functionality bugs, frustrating app hangs, rage taps, and rage quits. These are completely invisible to standard crash monitoring. Think about how this happens technically. Imagine your API gateway returns a 200 OK status because the network routing succeeded. Awesome. But the downstream microservice actually timed out and sent a malformed JSON payload, maybe just an empty string instead of a user profile. The mobile app receives that 200 OK, tries to parse the missing data, and simply hangs. There is no hard crash. The user is just staring at an infinite loading spinner. They rage tap the screen a few times, get frustrated, and close the app. Your back-end metrics show a perfectly successful 200 OK transaction, but the reality is a completely broken experience. At the end of the day, the 9s on your server dashboard literally don't matter at all if your users aren't happy.
Which brings us nicely to section 2, overcoming mobile domain challenges. What's really interesting here is the vicious cycle of technical friction that prevents teams from adopting better observability in the first place. Why is it so incredibly hard to get this right on a mobile device?
Klein, who's a huge voice in the observability space, outlines these 6 specific bottlenecks. He shows exactly why we can't just stream all data constantly from a mobile device without totally destroying its performance. Let's break these down because they're absolutely critical. First up, long release cycles. If you miss a log line of the backend, you deploy a hotfix in 10 minutes, right? On mobile, adding a simple log can take weeks due to App Store review cycles and users who just refuse to update their apps. Second, metered data plans. Your users pay real money for their cellular data. If your app is constantly streaming heavy telemetry in the background, they'll notice their data draining and they will uninstall your app, no question. Third, sporadic connectivity. Users walk into train tunnels or drive through rural areas. If you don't batch your data carefully, data loss is just the norm. Fourth, unplanned terminations. Mobile operating systems are ruthless. If they need memory, they will kill your background app without warning, instantly dropping any telemetry you had sitting in volatile memory. Fifth, high cardinality. If you decide to tag every single log with unique device ID, user ID, and complex state metadata across hundreds of millions of devices, your indexing costs on your backend observability database are going to be astronomically high. And finally, naive local storage. If you try to solve the connectivity issue by synchronously writing all your logs to the device's local disk, you're going to block the main UI thread. Disk I/O takes time. If the UI thread is waiting on a log to write, the app's frame rate drops below 60 frames per second, it starts stuttering, and you severely degrade the user experience just by trying to observe it. It's a total catch-22.
And this is exactly why Matt Klein says, in some ways, mobile observability is the final frontier of observability practice. You cannot brute force back-end strategies onto the front end. It just fails. We are truly at a frontier that requires a bespoke, from-the-ground-up engineering mindset. We can't just open a simple always-on pipe that streams everything from the device to the server. The database costs alone would bankrupt us, and the performance penalty to the user would be completely unacceptable. We need a fundamental rethink.
So how do we actually solve this? Let's move to Section 3, local storage in real time, and see how we pivot away from that dumb data pipe into a highly specialized solution. This is the ultimate engineering dilemma. We're really stuck between a rock and a hard place here. On one side, developers desperately need incredibly rich, granular data to debug complex user issues, especially because those long App Store reviews mean they can't afford to push a fix without knowing exactly what went wrong. But on the flip side, ingesting all that telemetry from hundreds of millions of devices all the time, that is a financial and performance non-starter. We have to respect the user's finite resources, their battery life, their data plan, and their CPU.
The breakthrough solution to this dilemma is a clever combination of two things: optimized local storage and a real-time control plane. Let's dig into how this actually works. Instead of streaming everything, developers log heavily to what's called an on-device circular buffer. If you need a quick refresher, a circular buffer is just a fixed-size block of memory. When it fills up with logs, it automatically loops back and overwrites the oldest data. This is brilliant because it ensures the logs never bloat the user's phone storage. Plus, this data is safely persisted to disk using asynchronous operations, meaning it survives app crashes without ever blocking that crucial main UI thread. But here comes the real magic, the real-time control plane. This is an intelligent, bi-directional streaming connection. Instead of the device blindly firing logs into the void, the server acts like a commander. It instructs the device on exactly what to look for. For example, the server might say, "Hey, we're seeing a spike in payment failures in Brazil." If the specific device is in Brazil and a user experiences a payment failure, immediately dump the last 60 seconds of your circular buffer to the server. If those exact conditions aren't met, the device sends absolutely nothing. It gives us an incredible fidelity dial. We get massive amounts of high-resolution, granular data exactly when and where we need it, and we pay almost zero ingestion costs when we don't. It's a game changer.
All right, so now that we have a technical solution to safely collect the data, we arrive at Section 4, centering the user experience. We've got the capability, but where do we actually point the lens?
Android architect Hanson introduces an incredible paradigm flip here. He argues that we need to stop chasing abstract metric spikes and instead start by finding the actual moments where a user failed to achieve their goal. Look at the stark difference here. Traditional back-end observability works left to right. It spots a sudden CPU spike at 2 p.m. or maybe a jump in database latency, and then asks, I wonder if this technical anomaly actually hurt any users. User-focused observability flips this entirely. It works right to left. It starts with the human being. It notices that a user specifically tried to add a product to their cart at 2 p.m. and failed, and then it works backward through the telemetry to isolate the underlying technical glitch that caused it. So what does this actually look like in code? It means recording telemetry that intentionally models and proxies human happiness. We really have to stop relying solely on auto-instrumented network requests or generic screen load times. We need to explicitly instrument the business logic. Think about it. Why do users open an app? To achieve a goal. They want to order food, buy a record, check their bank balance. Your code should have clear markers that say user intent, checkout process started, and later, outcome, checkout successful, or outcome, checkout abandoned. By capturing these events that model actual human intentions and linking them directly with the rich metadata gathered from the device's circular buffers, we can definitively quantify the true user experience.
Let's put this theory into practice. Moving on to Section 5, Case Study, Fake Burger App. This is where user-focused observability truly shines and proves its worth in a high-stakes environment. I want you to imagine the tension in an engineering war room on a Friday night at a fictional food delivery company we'll call Fake Burger. The product managers are panicking. A core business KPI, the successful checkout rate, has suddenly plummeted by 15%. This directly impacts revenue. The company is literally bleeding thousands of dollars a minute. So the PMs run over to the back-end engineering teams. But the infrastructure engineers pull up their Datadog or New Relic dashboards and say, look, our clusters are totally healthy. CPU's at 40%, database latency is 10 milliseconds, and the API gateways are returning 100% 200 OKs. It is definitely not our systems. Traditional monitoring sees absolutely no problem, but the business is hemorrhaging money.
Let's walk through how the mobile engineering team uses user-focused observability to hunt down the root cause. They follow this exact iterative flow. Notice, they don't start by guessing which microservice might be acting up. No, they start with step 1, detect the drop in successful checkouts, that failed user intention we just talked about. Then, they move to step 2, slice the data. Because they have rich on-device metadata safely pulled via their real-time control plane, they slice this failure data by client-side dimensions. This is data the backend literally never sees. We're talking about the specific app version, the device locale, the previous screen the user was on, or even the battery state. Finally, they move to step 3, isolate the metadata that perfectly correlates with the drop in checkouts.
By combining these failed checkouts with that client-side metadata, they can easily isolate what we call silent killers. These are massive revenue-impacting issues that traditional backend monitoring is completely blind to. Let's look at why these are invisible. Maybe they discover that a third-party SDK, like an ad tracker, is hogging the CPU specifically on older Android phones, making the checkout button take 10 seconds to respond. The user gets bored and leaves. The backend never saw a request. Or perhaps they find that a recent A/B test variant physically pushed the checkout button off-screen for users with a specific smaller device resolution. The user literally cannot tap the button. Because they can't tap it, a network request is never fired. Or even more subtly, maybe a localized currency formatting issue caused client-side validation to expect a comma instead of a decimal point. The validation fails silently on the device, blocking the checkout. In all these scenarios, the backend dashboards remain perfectly green, but the front-end observability catches the failure exactly where it happened, right there in the user's hands. This quote, "Production is where developer intent meets reality," perfectly captures the entire philosophy we've been discussing today. We absolutely must treat the front end not as an afterthought and not as a dumb terminal, but as the ultimate proving ground for our code. Every single time a user opens an app, it is a unique confluence of software, infrastructure, user traffic, and chaotic device constraints. It's spotty Wi-Fi on a moving subway train. It's a user trying to order food with 5% battery on a fragmented 4-year-old phone. That reality happens exactly once, in real time, and it can never be perfectly replicated in a pristine QA lab. Mobile and front-end applications are the literal interface between our code and human beings. They deserve observability that truly honors that incredible complexity.
Well, we've covered a massive journey today. From recognizing the unconstrained hostility of the front-end Wild West to navigating those severe technical bottlenecks of mobile environments, we learned how on-device circular buffers and real-time control planes finally give us high-fidelity data without bankrupting our systems, and finally, how centering the user experience allows us to catch the silent killers that traditional dashboards completely miss. I want to leave you with this final, provocative thought to consider for your own applications. If your infrastructure dashboards are perfectly green, but your users are rage-quitting because they can't even tap a button, are you actually observing your system? Stop settling for just monitoring crashes and start observing the actual experiences of the people using your software. Thank you so much for joining me to explore this vital topic, and I will catch you in the next explainer.